Hi, folks. So, welcome to the first talk that is not a panel in the language track. And we will enjoy now Piotr and talking about the nitty-gritty details that you need to keep in mind when you want to build a Docker image that really runs everywhere. Because as we know, containers run everywhere, but they don't, as we will probably now experience. So enjoy and have a good time.
Hello, everybody. So before we dive into the presentation, question number one to you guys. Do you use Docker containers? Can you raise your hand? Okay. Who's not using Docker containers? That's interesting, but like 99% is using it, right? So I think the topic is important. And who is using Java? Again, okay, you are in the right place. Thank you. Okay, my name is Piotr Malinowski, and I will be talking about Docker images. So shortly about me, I work at Revolut. I'm a Java engineer, and I did some research about my past. Recently, I just checked out. I just started with Java number 5 a long time ago, and I was traveling through a lot of framework stacks. Also, I was doing some DevOps tasks related to Docker and Kubernetes and OpenShift, all the stuff in the past. Right now I'm in Revolut. What is special about Revolut is that we don't use Spring in Revolut, but we use Java a lot. And what I do actually at Revolut is that I work in a team called Money Health, and this team is generally about helping you spend your money in a better way, basically to just waste your money less. So what we have here is a few screenshots from the applications, but I'm the person that's behind those features in backend. But what we do is actually we help you by providing you some statistics about how you spend your money, statistics on various categories. We also have a nice budgeting functionality that I really like to use myself. Also, I'm a customer of Revolut at the same time for a long time. So, and besides, the category management that we have in Revolut, there's much more that is going to happen, and we have very ambitious plans. So, I'm inviting you guys to apply to Revolut. It's also that we are a sponsor here, and we would like to have you on board. But from the engineer's point of view, what is really like the most interesting part for me is the challenges we have at Revolut related to the scale of Revolut. Right now we have about 40 million customers, and it affects us a bit, and the traffic, it's kind of a normal day traffic, it's taken from one of the monitoring tools we use. I'm not sure if you see the number there, but it's like 180,000 requests per minute. It's quite a lot, and we do it in the Java backend. Okay, going back to this the topic. So the first thing that you will get when you put the topic of finding best Docker images for Java application and you put it in Google, that's what you would get. And well, I could end this presentation here, and well, but I hope that I can explain later on what is possibly wrong here. And just to remind, what is that? That's a Docker file. And because it's a Docker file, it's a very short Docker file, by the way, with the inheritance, with copying the jar file, and with the command that runs a Java application. Will it work? Yeah, basically, it will work. So we could end up with this, but that would not be a perfect Docker image. Also, another alternative that is fast and could work is this command. This is a Gradle task called boot build image, the task that Spring Boot have. And again, you could use it, but during this presentation, I would like to explain what's happening here and how you could configure the stuff that's really heavily influencing the whole Docker image being created. And last but not least, probably that's too small for you, but the whole idea about this presentation is taken from when I joined Revolut. I got the Mac M1 laptop, and I was trying to use some Docker images with Java applications that we have in backend. And when I started running those Docker images, I realized that the startup time for Java application in Docker is about like 30 seconds. And it was like, I was surprised because I always thought that Java and Mac M1, this is a good match and it should be fast, but it wasn't. And I will try to also explain a bit what's happening here, why it is so slow here. Okay, and then, but before we go into those details of the Docker and Java, I would like to take you invite you for the time travel, and we will go to the year 1995. Because that's the title of the presentation, Write Once, Run Anywhere. And this is pretty fun because I didn't know about it earlier. That's the marketing term used by Sun when they released Java 1.0 in like end of 1995, 1996. And already at that time, when Java was created, that was the big thing. That was something that was special for Java. And if you read that news from Sun, you can already figure out there is a catch. So generally, of course, the idea of write once, run everywhere sounds good, but they already say in that news information that while you can run it everywhere, but on Mac OS it is delayed. Okay, so all right, and I have some diagrams from the past, and they look like they are from the past, and it's on purpose. These are probably original Sun diagrams from the like 990s, and if you look at it, well, it looks very nice. Basically, I mean, Java is a programming language that we use a lot, and we don't think about the basics. And here, but I have to say it again. The idea of write once, run anywhere, it originates with the idea that we have a Java program, let's say a file with class, that it's transformed, compiled into some bytecode or intermediate language, and that this code is run by the Java virtual machine. So in order for you to run the application, well, you need to just switch the JVM. You know, that's as easy as writing a new JVM for the given platform. So you could do it. That's pretty nice, especially if you compare it to the competitors at that time, to C++, for example, or C, or any other language that had to be compiled on every platform every time you would like to run it. But this is not everything, and it's not enough for write once and run everywhere to be working. So on the previous slide, I was showing you the Java program that consists of just one class. But in reality, we have, of course, a lot of classes, right? So the engineers from Sun had a great idea that in order to run the Java application, well, we need to pack it into some kind of package, right? So they created the jar format. It's from 1997, Java 1.1. And this format is very simple. It's very nice. It's just a zip file with Java classes and some metadata. As simple as that. But will this work like that? Well, it should work, right? But it does not work. The problem is with dependencies. If you have an application that does not use dependencies, and I'm pretty sure that nobody has that application. Everybody's in some dependencies, right? Then that we have a problem, because you cannot have, there's no way of having dependent libraries in a jar, at least in 1997. But again, this was not working. Well, you could do some magic, but you could not have dependencies inside the jar. So of course, people were smart and they decided, okay, in order to be able to do my Java minus jar, we go into something called jar hell. We take all the jars and we can approach this problem from two different angles. One is called fat jar and is a very standard approach everywhere. Another one is called Spring executable jar format. It's more sophisticated, and Spring Boot is using it for you. So the fat jar is very simple because it just takes all the dependencies, unpacks all the jars, and put them in one big fat jar. With Spring executable jar format, it's not like that. We put dependencies directly in jar, but this requires a custom class loader. So whenever you use Spring and Spring Boot, you will have a custom class loader that handles this external dependencies loading for you. But again, we now have a big jar that we can run. But how we would like distribute it? Because I mean, originally there was no idea of how we could distribute the Java application. There's no like installer or something. So that's the Maven Central 2004, and you could put in the Maven repository, of course, a lot of libraries, but you could potentially also put applications there. Please don't do it. That's not suitable for that, but you could do it. And I was doing it a long time ago. By this distribution was working this way that we've been uploading those Java applications to the Maven private repositories, and then they were like downloaded by the apps running somewhere without Docker. But we can do better, and the whole idea of Docker, it's 10 years later than 2004, they have a very similar marketing term to what Sun used. It's just called build once, run anywhere. But Docker goes a bit further, because Docker is not just the ability to build and run. Docker is also about distribution of the software. That's why I was trying to like show you the full path for Java. We have taken, we started with a compiler and JVM and ended up with Maven. And here, Docker is a set of tools for the whole lifecycle. And of course, Docker is not just for Java. It is for possibly every programming language and every code you could run. But there is also one important information here, because in 2014, this DevOps movement was getting more and more attractive. So the idea of shipping faster was very important, and still is. And they recognized that the idea of taking the app with everything, not just with dependencies, but with like operating system and let's say JVM, and pack it together. So the idea here is it goes far beyond what was there for Java. And that's why I think also Docker is so successful, because it handles it very well and eliminates this friction between environments. Again, architecture diagram is very simple one from 2014. These days, I have to just say this is not exactly like that, but for this presentation, that's not so important that Docker has progressed so much. So we have the Docker host, we have a client that runs those commands against Docker host. And we also have a Docker registry where all these images are stored. And the central part is image, but in fact, when you run the image, it is turned into a container. How you would then deploy those things? On the left, you see the traditional deployment model. On the right, you see the Kubernetes, let's say current model. However, in reality, these days, Kubernetes is not using Docker internally. Okay, it's a different runtime. It's not totally, but it's a different stuff. But Docker has like started the whole idea, so this is still valid. So we have moved actually the deployment of apps from the standard traditional app like libs operating system separated into a container deployment, which allows us to just do it in a more repeatable way and faster and more effective. But then, if we are going to dive a bit deeper into the Docker, I think the most important part here is how we build and how we create Docker images. And this is the explanation of how the Docker image format is created, and it's pretty smart. Those things on the left are the latest edition. I mean, it's like 2-3 years already. So-called manifest list. This is a new thing. But whenever you would like to download a Docker image, there is a lot of HTTP calls that need to be issued to get that Docker image for you. So the first thing you do when you would like to reference or download the Docker image, what is the reference? It's like Redis :latest, for example. That's the reference to Docker image. It could be longer, but generally that's the short reference. When you would like to get that image, you need to find the manifest list for that image first. Then you choose the manifest for the given platform you are interested in. And if you have that manifest, this manifest consists of multiple layers. And the layer itself is just an archive. Pretty similar to what jar is. But here you have a list of layers. It's also important, it's not a set, it's a list. The ordering of layers is important. There's also a config that's associated to JSON file that describes how to convert the image into a running container. The important part here also is that both layer and config have a field called digest, because what Docker is using, it's called content addressable storage. So whenever you have a layer, it has a digest, and you get that layer but by digest, not by ID or whatever anything else, but the digest is it's the same time at the ID of the layer. And this is a good thing because it allows us to reuse layers, and it helps us to reduce the image size, and of course it's just the networking that's less being used. But there's one more thing that actually, or even two things that are not here on this diagram. That's the standard, but if you try to like understand what's exactly here and how it works, you will notice one thing. In the first place, there is no Docker file here. So if you just study that, these are like, I didn't hide it anywhere. It's just, that's the reality. Docker file is not a part of the Docker image. Docker file is a recipe for the Docker image. It's not the content of the Docker image. Another thing is that in Docker files, you have the inheritance. Basically, when you write a Docker file, you inherit from Docker image, some other Docker image. You write from, and you provide the base Docker image. In reality, there is no inheritance in Docker images. But whenever you provide the Docker file with the recipe to like inherit from something, it means that the Docker image itself will contain references to layers from the base image, but there is no information about the base image in the Docker image itself. Just an example here. I took some Docker images just to show you how it exactly looks like. So this is the manifest list for Eclipse, Temurin, JDK. You can see there's a list of manifests for different architectures, so you can choose the manifest. Then you have the specific manifest for this time is for AMD 64 with the size and digest. So you are able to download those layers by this digest. And the config, this is something probably that you see in some tools that can show you the content of the image. Okay, the first demo is there will be a lot of tools in this presentation. It's got a tool called Dive. It's a very nice tool, well, UI text, but UI that allows you to go into a given Docker image and check the content of it. So if you are unsure why the given Docker image is so big, you can go there and check. You can figure out what files have been, what is the content of every layer, how many layers are there. Also, Dive can show you some like analysis of the image. So we can like go through that and check what's happening. Since we have already, let's say, agreed that we don't need Docker file, and we know the Docker image format, then we can start building those images finally, right? And in this presentation, I focused on 3 ways of building Java applications with Docker. The first one on the left, you all know that, I believe you all know that. It's called classical and generic. Docker build or Docker buildx. So we provide the classic Docker file and then you have a Docker image. As simple as that. The other one, it's called build pack. I call it magical. I call it magical because it indeed does a lot of work for you, and you just issue a command and it kind of works. But in details, that's a pretty also interesting way to build a Docker image, and this is something that you probably do when you use Spring Boot, because Spring Boot is using build packs to build Docker images. And the third one on the right is a very Java specific way. It's a Google library that allows you to build Docker images as if it was an archive. We don't need Docker to build that image. It will just create those archives, add metadata, and will allow you to like just create a Docker image without any containers involved to build it. So this is a different approach. I also find it quite interesting. Going into the Docker file, so I have updated the original example a bit by adding some stuff that might improve the image. But in fact, the Docker file as a language is pretty advanced. Well, it's easy, but it has a lot of things that you could do. And because of that freedom, you really need to be very proficient and understand all the best practices to do it properly. So one of the things you should probably do is add labels to the image. Another one is you should provide for multi-platform support some information about our platform. Generally, it is well known, it's easy, it's simple, it's fast. You can do it like that. But there is a catch. If you see here, we are running, the image contains itself a layer with the application, and this app jar is a so-called fat jar. So it's like a very big file, one big file. And that could be a problem, especially for bigger apps. How do you run it? You just use command line, right? Nothing really serious happening here. But I use the Spring Pet Clinic as an example. So I would like to show you that these things actually run in reality and they work, and it's not nothing that we should be worried about. But if you look at how much time it takes, yeah, it's not. It also takes time. And here I'm building this Docker images, first for ARM64 and the next one for AMD64 platform. So I build it twice. And as you see, when I build it twice, There's no caching. I just need to rebuild it, spend twice as much time. Then, again, this magical, a very interesting project called Build Packs. And so it's itself a big topic, there's a lot of documentation about it, so I really recommend you to just go into the documentation and find out what can be configured. But just some of the summary about this tool is that, first of all, it's a standard part right now of Spring Boot build image stuff. It has a lot of nice features. It is configurable, it is extendable, it is quite slow. I'll show it later on. But it has cache that should work. And also it is multi-purpose, which means that it works for Java, but it can work also for any other technology. And I think myself that this is really cool, because if you are not an expert in a technology, some technology, BuildPack can just build quite a good image for you. You can just point at the BuildPack at the source code of that application, it almost automatically will build you a Docker image. So you can run that application without even knowing the technology. And how pack works? Yeah, well, it works with the pack command, and it of course starts with a jar file. Again, it takes a jar, but it does some magic to the jar and creates the Docker image by looking into the jar, detecting what's inside, finding some metadata, and creating, downloading the JVM for you, and everything is kind of automated. You can configure a lot of environment variables that will allow you to just fine-tune it even further. Then we have this Jeep thing, which is it could be command line, but I'm using it as a Gradle plugin. It's very short configuration, and it will also, I would say, the biggest difference is that it is not using jars at all. The idea here is different. You compile the code, and as a final step of compilation, you just let's say assemble the code into the zip file, into the Docker file, instead of assembling it into a jar file. Because after all, a Docker file is a set of archives, right? A Docker image is a set of archives. So it's a bit different approach, which is fast and ends up with the target Docker image. And Jeep, there's again some short demo how you can configure it. I use the Temurin base image because it supports base images as well. You can provide on which platforms it will be built, and it will just build the image very quickly, and then it will upload the image either to local Docker registry or the Docker registry that's not local. Okay, but then so we have those three tools, three ways of building images, and how we can compare those Docker images, how to choose which one's better, right? So the first tip, you can figure out differences by using Dive, the tool I've shown you in the beginning. It has a very nice JSON output that you can create diff from. So here on this on the right side, you will notice that there are two layers that has been affected, and the layer on the top, the digest has changed, so the layer changed. The layer below, number 8, digest didn't change, but the ID changed. Doesn't matter, ID, we don't care about it. Also, there is like a Google tool called container diff. It can compare and list you differences between Docker images. So that's how you can actually spend some time and figure out what's happening inside. And going further into the image best practice, there's a lot of best practices and maybe even too much to remember. So what I would recommend is rather focus on few of them. And in this presentation, again, I cannot tell you about everything I wrote here, but I will focus on those blue ones. Okay, even though of course the others are important. So for example, you shouldn't be running Docker images as root. This happens, really, believe me. You should name the images properly. The image itself should be traceable, which means that it should have reference to the pipeline that built in the owner and so on. And of course it should be small, and in the end everything should be fast and simple, right? So there's a lot of those best practices, but I have to just focus on a few of them. So I go with multi-layered approach because I introduced those tools to be able to compare those tools, right? So and choose the one that fits the whole building process in the best way. And here I have this 3 tools, and this is the image layout for those tools. Starting from the top one, with BuildX, we have 6 layers created. With the biggest layer is the JVM itself. Similar with Jib, but you will notice one significant difference. With BuildX, there's the top layer is just the fat jar. It's one big layer, it's a fat jar. In Jib, we don't have a jar. We have the Java code separated into 2 layers. There's like libraries layer and a very small one, application layer, so the actual classes of the application. Then we have pack, which introduces build pack approach, which introduces 21 layers. Some of them are really small. Of course, like the biggest part of it is the JVM, the JRE. But again, we still have separated libraries from the code of application, and there's also like a special layer for resources, like Java resources, plus some other stuff that is a part of the features of the pack. Okay, but what would happen if I do a small code change? How the images would change? If I make a small code change, let's say, I don't know, I add a new class to that's not a small code change. I change a string somewhere, right? Then when I use BuildX, I will have to rebuild the whole fat jar. So I will invalidate the whole jar and I will invalidate the whole layer. I will have to create a new layer, and it's possibly hundreds of megabytes. With Jib and pack, the small code change will just result in a very small layer that is changed and invalidated. What it means? It means that if I have invalidated just one small layer, the Docker push command will be much faster because I just upload the changed layer. Also, the Docker pull command will be much faster as well because I just changed a very small layer, and every other layer is already there on your machine. So that's something to just remember, that we can improve the download time by using multi-layers. But there is of course a catch. So generally, what you have already might be just good enough, and that's it. That's it, and maybe we should not take care about it because it's working fast enough. Another thing is there's a principle called separation of concerns, and from that standpoint, I think we should consider creating multiple layers, and every layer is like responsible for a different concern. But if you would really would like to dive deeper and have the best possible image, then you would probably need to do a frequency analysis. So for example, if you have just some libraries that change more frequently, maybe they need a separate layer. And you could do such a magic with Jib and pack. You can specify exactly which layers should contain what. Okay, maybe also there's a common discussion about whether we should build minimal images, if that's the best way to deal with Docker images. And I must say that in my opinion we shouldn't, because I checked the content of the Docker image. The standard Docker images, I also compared this across a lot of components in Revolut. So in almost everywhere, like 80% of the Docker image is both the JVM and OS base and the That's the operating system dependencies. That's it. That's 80%. And then libraries, of course, and application code. And you can see that application code is like about less than 1% of the whole Docker image. And application code is something that probably changes the most frequently, especially if you deliver frequently. So from that standpoint, it seems that the JVM and the OS does not change frequently. So you just download it once and you just reuse it and reuse it and reuse it over and over again. Okay, so my opinion, we should rather focus on consistency and reusability and have a good standard in your company when to use the Docker image, same Docker image in multiple places for multiple components. And that's a very good starting point. So have this, let's say we have Revolut Java, it's 500 megabytes. It's bigger than those public images. However, we just reuse it everywhere. Okay, going into the multi-platform thing. So one of the topics from the beginning of the presentation. So first of all, do we need multi-platform? And I thought that not really. We've been all using Intel processors for many years, even though Java started with like Spark and so on, but we forgot about it. We've been using Intel everywhere. But now we have those Mac with M1s, and there is even more things happening, interesting things happening in the market of servers and cloud providers that they started to provide machines in the cloud that are based on ARM processors. And this is pretty cool and pretty fast and cheaper than Intel. So what's blocking us from using this opportunity and run Java on ARM? Well, what's blocking us? Well, not multi-platform images are blocking us. So we should, in my opinion, invest some time and build multi-platform images, not just for local development, but try to doing it also for the cloud. How you can do it? The simplest possible way is to use Docker buildx. You can specify multiple platforms and this will run. It will take some time, unfortunately, but it will run. If you look deeper into the multi-platform feature, this is something that was added, quite recently to Docker, is that you can actually build on every CPU. You can build almost for every platform. It's called cross-compiling, but in Java world, that does not make sense. But the idea here is that we are using the feature of Linux kernel that allows us to register some handler for some binary format. So whenever you run, let's say, a Docker image, a Docker container on your laptop, and it's aimed for a different processor than you have, the QEMU will be used. And this is the explanation why the Java startup time it was so huge, because I was not using my processor, I was using emulation, and it's like 10 times slower, at least 10 times slower to run such application. So be careful about it. You can run any Docker image almost on every platform, but this will be emulated and this will not work as you would like it to work. By the way, how you could find the image platforms? These are the commands you could use. All of them, they will show you the information, but in a different way. So yeah, so you can check it. And then I also did some benchmark. I said, okay, maybe we should, everybody would like to have the fastest possible build pipeline, right? So, okay, let's try those tools and check which one's the fastest. And what I realized is that even though Pack is slow, but it's like, I don't know, 15 seconds difference. So for a bigger application, probably it just that's not so important. In some cases, it could be, especially if you would like to build multi-platform images, then you have to invoke this process multiple times. So then you can think of using Jeep or even Docker buildx because it's much faster than using build packs. Okay, the next thing about the best practice, especially for Java, is how you run Java in Docker. So what parameters you should provide? Well, that's the real example from the apps we use that we configure in Revolut. Like 80% probably of backend components have that setup or very similar. So the one thing, of course, this is like a huge topic again. The thing that we should always be thinking of when we run things on Docker, either it's locally or Kubernetes or anything else that uses Docker, is to set those constraints on Java. The RAM percentage that's being used by Java, it's RAM percentage of the amount you give to the container. Active processor count, same thing. It's questionable whether you should set it or not, but generally, if you know how many resources you are giving, how many CPUs you are giving, you should probably set it, because it will improve the performance. What also we use in Revolut, we have very nice monitoring tool that we use. It's called New Relic, and you have to configure it, right? Next thing to remember, certificates. We forget about certificates unless they expire. If they expire, then everything stops working, right? So we need to have a way to externalize certificates, let's say, out of the Docker image, so you can like quickly change them. And same with configuration. In Revolut, we are not using environment variables for that purpose. We are using a YAML file where the whole configuration of the app is stored. However, passwords are not in that file. Passwords are in Vault. We are like connecting while running. So we don't use like secrets from Kubernetes. We just integrate with Vault. But what else you could do here? You could get some inspiration from Buildpack, because Buildpack has a very nice memory calculator for Java. And memory in Java is very important, as you will know, and it's worth spending some time on to properly configure that. What else I would suggest is like checking the flags that you can set on the JVM level. For example, I find myself interested in the flag that will stop the image, exit the image when there's out of memory error. So you will like have an information that there were some restarts of application due to that. But of course, this is again can be discussed. Important thing is that we have the ability to print all the JVM flags and figure out. It will tell you exactly what is configured for Java, and then you can just choose the things that you would like to optimize. Last but not least, I mentioned earlier, when you run the Java apps locally, please specify the limits for this container, especially memory, because if you don't do it, you will probably give too much. Also with CPU, that's again, you could, but if you don't do it, it will work, but it's generally a good idea to set the limits. And of course in Kubernetes, that's the same thing. Next thing, I mean, probably guys, do you use Docker Desktop? It's like a commercial software now, so. So using. Well, we at Revolut, we are not using Docker anymore because of the licensing and the costs. So we had to figure out what tool to use to like to dive, to check what's happening inside the Docker daemon. And I use like Lazy Docker. It of course gives you the information about the Docker image, but it gives you information about running containers as well, like with also some statistics, configuration, environment variables, and so on and so forth. It's highly recommended by me, and of course you can do some actions. Of course, I run it in the background, and when I run like automated tests, I just sometimes check what's happening. Okay, getting into the conclusions. I mean, we have a lot of principles in IT generally. I mean, maybe you can recognize them. So the first one on the top is keep it simple, stupid. Right? Other one on the left is you ain't gonna need it. And the third one, it depends, right? And all those rules, they make sense. They make perfect sense. So, but balancing this require you to, to measure things. So I think we should, if you would like to optimize stuff, you can always optimize it. But you need to know what you want to achieve, and then choose the tools that allow you to do it. So measure, then act. And we'll give you some examples on what you can measure. You can like measure commit on deployment frequency. If this is a high frequency, then maybe it's a good idea to have separated layers for applications, because then you will save a lot of space in the registry, but also your apps might start faster, might download faster, and use less networking. Maybe you would like to optimize the build time. Maybe it's just too long. So maybe it's a good idea actually to use tools that build the Docker image faster. Build cost is of course like a bit more related to the cloud and how much you paid for building process. So for example, if you are using emulator to build a Docker image, it costs you much more because it's much slower, it takes much more CPU. So maybe it's worth using the native CPUs. Push time and pull time, yeah, I mentioned earlier. That's the idea, that you might want to optimize the time it takes for the Docker to download the image or upload the image. Also, the uploading is interesting because normally it's a part of the CI/CD flow. You have to push the image somewhere, right? So it takes time. So if you reuse a lot of layers, then the push will be fast. And based on that, I was showing you those multi-layered images. There is one thing I didn't mention earlier. So we can have a lot of layers, but layer is also a cost, because if you download a layer, it's a separate HTTP call. So if you have too many layers, you just have to issue a lot of calls, and this of course generates the traffic. So let's be careful about not adding too many layers, especially if they are small, then it might be not worth the price. And also you have the network bandwidth. Sometimes you might have problems if your Docker image is like, I don't know, 8 gigabytes. That could be a problem. So measure, then act. And when it comes to it depends, I have some recipes that how you can talk to your managers, okay? So if your manager is telling you that you should stick to our company standards, there's no reason to change anything, that's probably, you should use Dockerfile. There's no other way. But also this Dockerfile makes some sense. If, for example, the storage for images, you don't pay much for this, and you have very custom built logic, then okay, let's just use Dockerfile. You can configure Dockerfile in a way that it will allow you to have multiple layers, but it's a bit of work, but you can do it. You can also generate Docker files and then use them. So there's a lot of freedom. You could do it. If your manager is telling you we don't have time to do it, and of course like your colleagues are saying that Spring has it, okay, you can use Pack, but be informed, and you can always say yes, we can use it, but it does not support ARM, for example. Okay, and but other things are pretty cool in build pack. It's also slow, as I mentioned, but there are some nice extra features, especially regarding security, that could be really good. And lastly, and this is the real situation I had in my DevOps life before, that I was not allowed to use Docker daemon in the building process. So I could not run Docker. So what did I did? I used Jib because I don't need Docker. So I could build a Docker image without having Docker. And this is pretty cool. And also if someone tells you that we do things like Google and we should stick to what Google does, it happens. Yeah, and it works. And the Jib is a pretty nice library. But also it's configurable. It's when you have limited storage, then also it might be worth investigating it. Last but not least, okay, what is I call it local CI duality. I think that for us developers, the most important thing should be to have this fastest feedback loop possible. But the problem here is that our code and our tests are running into different places. I mean, they are running as a part of DevOps pipeline, and they are running on the bare metal laptop. And these days, these laptops are much faster than much faster than the machine that you are using to build your application in the CI. So it's a different also architecture and different platform. So from that standpoint, I think it's worth investing some time to have your setup as fast as possible. So you don't spend a minute for a build, but you spend, let's say, 15 seconds. And when you are using multi-platform Docker images, especially, for example, if you use test containers, please check if the test containers you are running, the Java apps, let's say Kafka, do they run natively or do they run in the emulator? Because if they run in the emulator, they will be super slow, but they will work. Okay, I think we have some time for questions.
Thank you, Piotr. The problem is we actually don't.
Okay.
You can rush to at least one. So
44 minutes.
Can you comment on how Docker image size affects storage and startup time in final environments? For example, Kubernetes. Every image needs to unpack in full.
Yeah. Every image needs to pack in full. That's not necessarily true. It changes, because there are some features for like streaming the Docker image when you run it. But generally, that's the case. Whenever you would like to run the image, it has to be downloaded on the Kubernetes node first. and then turn it into a container and run. That's the standard thing you do it. And that's why reusable makes sense, because if you have all your components use the same layers, then you could just download it once and then all components will like benefit from it. But generally that's the case. You need to download those layers to be able to run the image.
All right, I think the other questions then we need to take to the outside meeting booth. Thank you very much for this great talk.
I invite you guys to visit the Revolut stand, and of course you can ask me questions there as well. We are hiring, of course, so you are all welcome to join us in Revolut. Thank you very much.